Microsoft Azure finally did it. We finally have a potentially good solution to run our applications as serverless workloads. Before I explain what Microsoft is cooking, let me give a very brief overview of serverless solutions so that we are on the same page of what it is and maybe what it isn't. Serverless is all about not caring about the underlying infrastructure. When we run serverless workloads, we do not care where it's running, how it's running, and so on and so forth. All we want to do is provide our code to a service, and that's about it. It's up to provider to figure out what to do with our code. Now, I am fully aware that there's not a deep explanation of all the details about serverless workloads. I do not have time for that in this video. If you want to know more about serverless workloads, I made a video about it a long time ago and you can check it out. The link is in the description. What is important for this conversation is to understand that not all serverless solutions are functions as a service. There are different flavors, and functions as a service is only one of them. That's how it all started. But today, I can argue that functions as a service are not a good solution, or most of the time they're not a good solution. You need to have very specific needs, very specific goals for functions as a service to be the right solution for a significant percentage of your workload. An example of functions as a service, the most known, the best known, and very widely used example is Lambda, AWS Lambda. It is considered a pioneer of serverless workloads, and it's not a really good one. I mean, it's not bad. Functions as a service is a good idea, but it can serve only specific use cases. You need to have very specific needs to use functions as a service, lambdas, and other similar solutions. Simply put, there are too many limitations. You need to write functions which are small, tiny, smaller than microservices, smaller than anything else, and you need to have a lot of them. They're very limiting, potentially complicated, and they are designed to lock you in. Once you start using something like AWS Lambda or something similar, there is no way out, there is no escape, and on the other hand, you will be able to use them only for very specific needs. You're unlikely to ever use something like that for a significant percentage of your workload. A potentially better flavor of serverless workloads is containers as a service. Hey, this is my image, run it, I don't care how. And that's brilliant because it combines the best of both worlds. I can write my application any way I like, I can do whatever I want, as long as I can package that something into a container image. I should be able to run that something as a serverless workload when using containers as a service. Actually, that's not really true. Today, most of containers as a service solution require your applications to be stateless, so you can move stateless workloads to that way of running them, but that is going to change soon, pretty soon. Anyways, containers as a service provide clear separation between what we should do and what the provider should do. We should write our code any way we like, package it in a container image, and it's up to a provider to figure out how to run it efficiently. And right now you might be wondering, hey, why are you talking about serverless and containers as a service and all subjects? Well, I have exciting news, or maybe it's not so much of news depending on when you watch this video, so I'm not going to call it news, but what I am going to say is that Microsoft has a new solution called Azure Container Applications or Azure Container Apps. And it's very exciting what they're doing. The idea is very simple. We need to give Azure a container image and Azure is going to take care of the rest. It will handle HTTP traffic, event-driven processing, CPU and memory load, and it will scale our applications from nothing to something depending on the workload. Let me show you Azure Container Apps as a better attempt from Microsoft to make containers as a service, because this is not the first time Microsoft is attempting to create a good containers as a service solution. We already have for a long time Azure Container Instances, which are terrible. It's a joke. It is not worth the effort. Nobody should use it, except maybe tiny companies who have, I don't know, like hobby sites or something like that. So what I'm going to show you now can be considered Azure's attempt to reload the story about containers as a service. If you're already burned by container instances, to not give up hope. This one is good. Container Apps is a good solution. I'm very excited by this because right now Container Apps are in the preview mode. This is not yet GA, this is early, and I'm already very excited. So let's go into the demo. Let me show you how it looks like. Since this is Azure solution, I will assume that you already have AZ CLI. You must have it, unless this is the first time you're using Azure. And if I'm wrong, I do not understand why you're watching this video. Go somewhere else. This is for people who already have at least 1 day experience with Azure, and that means that you have AZ CLI installed. I will not show you how to install the CLI, and I will assume that you're already logged in. So we're going to skip those silly steps that you already did and jump into installing the extension for Container Apps. And by the way, I have a gist with all the commands, and the link to the gist is in the description of this video. So if you want to follow along, check the description. The link is over there. So I will execute AZ extension add and then the source with a very long URL, and I will say yes. I do not want you to ask me any questions. In the future or present, depending on when you're watching this video, you might not need to install the extension because Container Apps are going to be part of AZ out of the box. But since at the time of this recording, it is still in the preview phase, I need it and you might need to install the extensions. What follows next is a set of steps that under normal circumstances would not be needed, but this is Azure. Azure solutions are sometimes extremely simple and sometimes they're silly. Services are sometimes well integrated and sometimes they're not. And Container Apps, at least at this moment, fall into the it's not so easy, you need to do too many things to set it up type of solution. So I will go through the setup steps very quickly. I do not want to spend too much time on them because they are frankly boring. So I will register the provider in the namespace Microsoft.web. I will need to create a resource group, and since resource groups need to be unique, I will create a unique string for the resource group and store it in an environment variable. I will be running my applications in Canada. And the reason is very simple. I never run anything in Canada, and I thought that they deserve a bit of attention as well. So big hello to my Canadian friends. I do not know why I chose you for this demo, but hey, my application will be running in Canada. Your applications can run anywhere you want as long as Container Apps are working in your region, and you might need to check the documentation because right now Container Apps can run only in a selected number of regions. Eventually Azure will propagate it to all the regions, but right now I think that there are 5 or 6 of them, and Canada, hey Canada, is one of them. So I will create the resource group. Then I will define a few environment variables, one for log workspace and another one for Container Apps environment. I will explain what environment is later. For now, I'm just defining the variable. And then, since I want to collect the logs from my applications, I will create a log analytics workspace. And then I will retrieve the customer ID from log analytics, as well as the shared keys also from log analytics. That was a bit too much if you ask me, but hey, it's not that complicated, really. In any case, I'm finished with preparations, and now I can create the first application. Or no, wait, stop. I cannot create the first application because I need to create an environment, and environments are potentially a good thing. So let's talk about environments. In the context of Azure Container Apps, environments are a sort of security boundary. All the container applications that we deploy to an environment share the same virtual network and write logs to the same log analytics workspace. Conceptually, an environment is similar to a cluster or maybe a Kubernetes namespace. It's a way to group applications that should work together, communicate with each other, and live in a tiny bubble separated from the rest of the system. So let me create an environment by executing AZ Container App environment create. I'm going to give it a name, the resource group, the logs workspace ID, and the logs workspace key, and the location. Now that it is a bit clearer what an environment is, let's talk about containers. I will not give you a lecture about containers, what is a container, how containers run, and so on and so forth. You know that stuff. Instead, I will just talk about what makes containers special in the context of Azure Container Apps. First of all, good news, any container image can run as Azure Container Apps. So if you have an image you can run it. There are no special requirements, like some other solutions force you to have a specific base image, or to implement specific interfaces, or to use specific languages, and so on and so forth. No, in this case, you can use any container image and run it as Azure Container Apps, and that's absolutely awesome. No significant restrictions, at least not so far. What is important here is that Azure Container Apps run in a Kubernetes cluster. You cannot see that cluster, you cannot touch that cluster, but it's running inside Kubernetes clusters. That does not matter much for you as a user, because all you have to do is tell Azure, hey, I have this container image, run it. But it might be important if you want to understand the details. And since it is Kubernetes, that means that containers are running as pods, and that means that we can run one container or multiple containers deployed together. Because at the end of the day, container apps are pods running in a Kubernetes cluster that you do not control, that you do not care about. The only other thing worth mentioning at this moment are the limitations. Privileged containers are not allowed, and they should never be allowed anyway, so that's not a real limitation. And you must run Linux containers, at least right now. So if you're hoping to run your Windows applications as Azure Container Apps, well, it's not gonna happen, at least not today, maybe in the future, who knows. But right now, you cannot run Windows applications. And that tells you something about the opinion Microsoft itself has about Windows in Azure, right? Windows servers, Windows applications, I wouldn't place my bets on that in general, not even in Azure. But that's not the subject of this video, so let's move on and create the first container app. Be patient with me, because the command is going to be on the long side. I'm going to try to figure out how to shorten it later. For now, let's just go through it and execute AZ container app create, give it a name, the resource group, and the environment. We will use one of my images. The port is 80, ingress is going to be external, meaning that the application will be accessible from outside of the environment. I want to have FQDN for accessing my application. I'm going to give it half a CPU and let's say a quarter of gigabytes of memory. And there will be maximum of 3 replicas. The minimum is 0 by default, so it can scale to 0. When there are no requests coming in, it will scale to 0. And I'm going to give it 3 replicas as the maximum. And here it goes. Okay, this is one of the silly things. Actually, I knew in advance what will happen, but I wanted to show you what was my first frustration with container apps when I started using it a while ago. We cannot specify any amount of CPU and memory. We need to check the table and choose from one of the specific combinations. If you want quarter of a CPU, then there must be half a gigabyte of memory. And if it's half CPU, then 1 gigabyte of memory. And if it's 0.75 CPU, then 1.5 gig of memory, and so on and so forth. So we cannot have any amount of CPU and memory. Those two are correlated, and we need to select from one of the tiers, let's say. That's a bit annoying, but it's not the end of the world. So let me repeat the previous command, but with the correct amount of memory and CPU. And now it is working, it is doing something, let's go. And I got an address through which I can access the application. I could have used my own domain, subdomain, whatever I wanted, but I do not have an available domain for this demo, so I let Azure auto-generate the address for me. So let me open it in a browser and double check that it really works. And as expected, it does work, at least for now. I'm going to show you cases when it doesn't work, even though it should, but we'll get there in time. Now, I do not want to run my applications like this. I do not want to memorize all the arguments, especially when there's more than 2 of them. So I will delete this application and we're going to start over, but by defining the application in a file. So let me delete this one and start over. So, I do not want to remember all the arguments, especially since there are more arguments that I would like to use, or to be more precise, that I have to use. There must be a way to define it as YAML or JSON or something like that. My first reaction in situations like this is to consult help. So let me execute AZ container app create -- help. There are quite a few examples over there, and that's amazing. I love when I get examples right away. All I can do is specify parts of the application. Like, hey, those are the APR components that I can specify, but that's not what I want. I mean, I do want to use the APR, and I'm going to go through it, probably not in this video, in some other video. Anyways, the point is that I want to define everything, not only a fragment of the definition of an application. And examples do not help me with that. So let me take a look at the arguments. There are actually quite a few useful arguments, but at this moment, the only thing I want is to find out how to define the application. So scrolling, and there we are, --YAML. Path to a YAML file with the configuration of a container app. All other parameters will be ignored. Excellent, that's exactly what I need. Except that help does not give a clue about the format of that YAML. Where can I find the schema, the specification of the YAML that I can use? Are there any examples? What should I do? So I'll have to go for plan B and go through the documentation. Now we'll skip the torture of you watching me reading the documentation because that takes time. I will just fast forward to the end of the process and tell you that I did not find a single clue about the format that I can use to specify YAML. At least not right now while we are still in the preview mode. By the time you're watching this video, the documentation could have been updated. Maybe there are examples, maybe there is a schema and so on and so forth. But right now, for me, there is no help. I cannot use YAML because I cannot know what to specify in a YAML file. But not everything is lost. There is hope. I can use ARM or Azure Resource Manager and specify what I need to specify in that format, which is very unfortunate. I do not like, no, wait, that's wrong. I do not dislike, I hate ARM. I think it is a silly format. I think it is convoluted with random things that I do not need. And it's JSON. Who uses JSON today? But since I do not have a better option, ARM it is. Let's use ARM to specify what an application is. Now, as far as documentation goes, there is no way to specify container app directly. Instead, we need to define a deployment group. And inside a deployment group, we can define container apps as resources. I have two parameters, an environment and a tag. And then inside of resources, I'm defining the name, the type, the API version, kind, location, properties, and so on and so forth. I'm defining container app as being a resource of a deployment group. It's not ideal, it's not good, but it is what it is. So let me just roll with it. So now I can have a command with only a few arguments. I will execute az deployment group create. The resource group is whatever the resource group is. And the template file is the one that we just explored. And then I will pass the few parameters, one for environment and one for the image tag that I want to deploy. And that's about it. Let me press the enter key and see what we'll get. And it failed. What is it now? Let's see. What is the problem? The scale options provided for container app is incorrect. The value must be positive. That's correct. It is already positive. And max replicas must not be less than min replicas. That is not the case. So that's not the problem. So the last clue must be the correct one. The max replicas must not be bigger than 10. Come on, that's insufficient. Having only 10 replicas might be good for many, but not for all. I can easily have an application that needs more than 10 replicas. 10 replicas is just not enough, at least not for all the use cases that I have. If I would have a hobby site like, hey, this is my collection of napkins, one replica, maybe two, that's enough. But when we're talking about serious usage, especially in serverless world, I need more than 10. It is still in preview, it is not GA, and I hope that the reason behind this limitation is that Azure does not yet feel confident to run it at scale, and that the limitation will be removed, or that the maximum number of replicas will be increased when the service reaches GA. I really hope that this is temporary. So let me edit my definition and change the number of replicas from 25 to 10. That's the maximum that I can have. And now I can run the same command again and see whether it will work this time. It is running and running and running and running and running. I have a feeling that it takes more time when it's deployed as part of a deployment group than directly, but I might be wrong. Let's get back to it. It's running, and there we are, it's deployed. And we got an output, but that output is almost useless to me because that's not the output of container apps, that's the output of the deployment group, and I do not really care about it. I care about the status, about the output of the application itself, which is hidden because I'm not deploying it directly but indirectly, and anyways, it's a mess. I will have to look for the information I need elsewhere. Specifically, I need the address through which my application is accessible, and I do not have that here, so let's explore how we can see the status and other useful information about container apps. We can, for example, list all the container apps by executing az container app list, and I'm going to output it as a table because for this specific query I think that that's the most useful format to see. Hey, a list of something should be a table, shouldn't it? There's the name, location, provisioning state, succeeded, hey, success, and resource group and FQDN. I really care about FQDN, but that's not the FQDN that I'm looking for because that's the address of that specific revision, and we did not yet speak about revisions, so I'm going to park that for now and find the information I'm looking for, the address to be more specific, through some different ways. I should be able to see all the details of a specific application, and indeed I can do that through az container app show, and then I pass the name and the resource group, and this time the output will be YAML because when I see the details I like YAML, sue me. Now there is something wrong. I cannot access the application, I cannot reload the application. I think that something is messed up with Ingress. Either I did not specify it correctly, or deploying container apps as deployment groups does not work as it should. Simply put, it is preview, it should be working, it doesn't, but I will ignore that because, as I said, it's preview, it's not the final version. I will give Azure a pass on this one and continue using the CLI instead of ARM because it doesn't really work well. And on top of that, I do not like ARM. What matters is that it is preview, so problems are to be expected, that you can define the application through ARM format. Hopefully YAML will exist in some near future, and that I'm going to go back to the CLI because that simply works better. So let me delete the application I just deployed and deploy it again through the CLI, the same command as before, so no need to explain it again. And there we go. Now I have the correct output, I have the output I'm looking for, the address, I can open it in a browser, and the application is working, it is accessible, and so on and so forth. And since we're talking about different ways to observe the status and the description and the details about the application, I should probably cover logging, and we can see the logs not directly through the application, but through log analytics by executing the command az monitor log analytics. I want to query something, and this is the workspace, and then comes analytics query that says container app console logs underscore cl pipe where container name underscore s equals dot, and pipe it to the project and the log and time generated and take 3. This is madness. Who is interested in logs of a single application and is willing to execute that query? I mean, if I would be looking at the system as a whole, then of course I have to query, but I do not want to query the system. I want to see the logs of that specific application. I should be able to say, this is the name of my application, give me the logs, and not deal with this query. But that's what I have to do, and that's what I will do. So let me finish the command and output it as a table. And there it is, those are the logs of my app. I'm still annoyed that the command is so silly, but at least I was able to get the logs of my application. Now, don't take me wrong, I do think that we should be able to query the whole system instead of observing logs of a single application, so queries are cool, but not always. In this specific case, what I would like is something equivalent to kubectl logs or Docker logs or something like that, where I just need to specify the name of the application, and that's about it. Hopefully, this is temporary, and Azure did not yet figure out how to deal with logs better. Enough about that, let's talk about scaling. Workloads deployed through Azure Container Apps are scaling automatically. Out of the box, we are getting one replica of an application for every 50 concurrent requests. That was too simplistic of a formula. It will not always be one replica for every 50 concurrent requests, but in simplistic terms, you can think of it that way. If there are 200 concurrent requests, we will have 4 replicas. If it drops to 50, we will have 1. If there are no requests, we will have 0 replicas, and we would not be paying anything to Azure because there is no traffic coming in. That is the default behavior which we can change. change. We have a huge amount of options we can use to define how will our application scale, when it will scale up and when it will scale down. And those options are provided through CADA, which is Kubernetes event-driven autoscaling. CADA is an amazing project which I will not explore today simply because it deserves a video on its own. And I will do a video, I promise, but not today. So those are the first two options for scaling. We can scale based on HTTP requests, on anything that is supported by CADA, and there is also an option to scale based on memory or CPU usage. However, if you do choose to define scaling based on memory or CPU, it is important to note that in those cases, our applications cannot scale to 0 replicas. Now let me generate some traffic so that we can see two things. First of all, I want to see whether container apps can handle traffic. How do they behave when exposed to moderate traffic? I will not even generate a lot of traffic, just a little bit, and see whether everything works. And on top of that, I want to see how the scaling itself works. Will Azure apps really scale to whatever number of replicas they should scale, and whether it will go down later on when there is no traffic. And for that, I will use ddossify, which is a handy tool to generate traffic. So I will run ddossify-t with the address, -n, which is for the number of requests that it should generate, -d for duration, in this case 60 seconds, and -l for the type of the test I want to perform. In this case, I will do incremental test, meaning that it will start slow and then start increasing the number of requests. And it is running, and it will continue running for approximately 60 seconds. I will fast forward because it is boring to watch the screen for 60 seconds just sending requests, and let's see what we'll get. To begin with, there were no failures. Azure and my silly application managed to handle all the requests. Now those were 1,000 requests during 60 seconds. It's not really heavy load, but still it gives us some indication that everything works well, at least so far. The second thing I wanted to check is whether the application really scaled, whether the number of replicas increased, but I will get to that later. For now, let's move into the next subject. Let's see how we can update our applications. Updating applications, or to be more precise, creating new revisions is relatively easy and straightforward. All we have to do is execute Azure Container App update, give it a name, the resource group, and the new image that we want to use. In this case, I will use tag 300. I think that the previous one was 2 point something. And then we wait, and we wait, and we wait, and there we go. The application was updated. That's all it takes. Now that was normal update, or to be more precise, rolling updates. While the new revision was being deployed, all the requests continue going to the old revision, and once the new revision was fully operational, all the upcoming requests started going there, and the old requests finished on the new revision, and so on and so forth. It's typical rolling update strategy. There's nothing special about it. However, we can do more than that. We could create a configuration that would tell the system to perform something that resembles canary deployments. We could say, hey, this is the percentage of the request that should go to this revision, let's say the new revision, and this is the percentage of the request that should go to the old revision. And then we can see how the new release behaves, and depending on the outcomes, change those parameters over and over again until we reach 100% of the new revision, of the latest revision, or until we choose to roll back. That sounds like progressive delivery, like canary deployments, but it's not really that. Those are manual operations. We would need to change the config every time we want to change the weights of each of the release, and so on and so forth. It is nowhere near what Flagger or Argo rollouts are giving us. It's not fully automated canary deployments or blue-green deployments. It is just giving us capability that we need to control manually, which is not what I really want, but it is better than nothing and better than what most competing similar services are giving us. I can guess that this will evolve over time. Right now it's not very useful, but it very well might be sometime in the future. Let's put it this way. There is a foundation for real progressive delivery. Now let me deploy one more release. Let it be 4.0.0. Now let's take a look at the list of all the revisions that I deployed so far. And I can do that with the command az container app revision list, give it a name, the resource group, and the output will be, in my case, table. And we can see that there are 3 revisions. That's correct because I created the application. That's the revision number 1. And then I updated the application twice. So that's 3 revisions in total. Now, one annoying thing is that revision names are auto-generated, and that's okay by default, but it would be really nice if I could specify the revision myself every time I update the application. That would make it easier for me to follow. I could have specified that the first one is 270 and the second one 300 and the third one 400, which would correspond with real releases of my application. But as far as I know, we cannot specify the name of the revision. It's auto-generated, and that's kind of unfortunate. But hey, it's not such a big deal. It would be nice though, but I can live with it. What is really interesting there is the number of replicas. We can see that there are 10 replicas of the first revision because I bombed that revision with requests. That's when I used the Dosify, and one replica of the other two revisions. Now it's been a while since I bombed my first revision with requests, and I expected the number of replicas to drop to 1 or even better to 0 by now, but that did not happen. By default, it is waiting for quite some time before it makes decisions to scale down or scale up, but it will eventually scale down, so I will wait for a while. I will go and get some coffee and come back and take a look whether the number of replicas dropped. So I'll be back in a couple of minutes. Okay, let's see what's going on now. Enough time passed, I had my coffee. Let me take a look at the revisions one more time. So the number of replicas of the first two revisions dropped to 0. The last one, the newest one, is still having 1 replica. That's because not sufficient amount of time passed since the last request I sent to that revision. If we would wait for a while longer, we would see that the number of replicas of the newest revision would also drop to 0 if there is no traffic coming to that application. And for the grand finale, let's talk about Azure Container Apps. I will start with cons, with the things that do not work well or the things I do not like, because the list of cons is actually much bigger than the list of pros. To begin with, the initial setup is kind of silly. I would like if that's all streamlined. If I would just say, hey, create the application, this is the resource group, and that's about it. You figure out what to do with logs and whatever else you need to do. So the initial setup is longer than I would like. But okay, it's not that bad, it's just that it could be better. We can choose between using the CLI or ARM. I'm not sure which one is worse. I really want to specify what an application is, store that specification in a file, push it to Git, and so on and so forth. But to do that, I need to use ARM, and I do not want to use ARM. I do not like ARM, and even if I would like ARM, or if I would want to use ARM, still there is no specification specific to container apps. It's generic, and it doesn't really work well. So CLI is the best option right now, and that's unfortunate. But there is light at the end of the tunnel. We know that YAML is coming. At least according to help, YAML should be there. It's just that it's not yet, or it's not documented, or both of those. I'm not sure, but I hope that it is really coming, because that's the important piece missing. There are no application-specific logs. They're all shipped somewhere, and then we need to query that something to get the logs. I like that when looking at the system as a whole, but when dealing with a single application, I would like to just get logs of that application and not logs stored somewhere that I need to query with some silly expressions. That's just not really nice. Traffic splitting is insufficient. I want progressive delivery. I want canary deployments and so on and so forth. We have to do those things manually, and I hope that Azure will consider it as a base for real progressive delivery coming later. I really hope so. Azure, please do it. Please do real progressive delivery. I would really want that. What else? Oh yeah, we have to choose from buckets, CPU and memory. We cannot specify just how much CPU and memory we want. We need to choose from some list, and that's also unfortunate. I would like to have the freedom to specify whatever I want, but hey, it's not a big deal. I can live with that. Next, we can have up to 10 replicas of our applications, and that's not enough, especially when working with serverless applications. And there are many other issues and bugs, but guess what? That's not a big deal. This is preview. Azure Container Apps are in very early stages, and I think that Microsoft is making the right move. I think it's a good idea to give it to people before it's fully GA, before it's fully finished, so that we can provide feedback, find problems, and so on and so forth. In other words, we are in early stages, and you can ignore almost all the issues that I mentioned because it's still preview, and I will judge it harshly when it becomes GA. For now, what I will say is, Microsoft, I forgive you all the problems, all the issues, all the missing things, because this is preview. The project is in early stages. Now let's talk about pros. Let's talk about advantages. To begin with, it's CaaS. It's containers as a service flavor of serverless, and I think that's so much better than functions as a service. for majority of workloads. There are cases when functions as a service is great, but being able to create container image and say, hey, it's not your problem what's inside of this container and I want you to run it. There are no special APIs, base images, frameworks, libraries that I want to import and so on and so forth. Here's the image, run it. That's the best model of serverless we have today. Next, scaling supports SCADA or Kubernetes event-driven auto-scaling, and that's absolutely amazing because it opens the doors to huge amount of possibilities when scaling is concerned. Then there is Dapper. Dapper project is great. Now, if you're not familiar with Dapper, just let me know and I will create a video. Actually, I will create the video even if you don't tell me anything because it's really amazing and you should know about it. And then we have revisions, which is a really great way to keep track of what's going on and to make sure that we do not mess it up, that we can roll back, that we can have traffic splitting, maybe canary deployments one day, Microsoft please, and a few other possibilities. All in all, Azure Container Apps is potentially amazing. I'm saying potentially because it is preview. I cannot judge it as if it's GA, but it has a lot of potential and I'm really looking forward to see where it's going from now on. One thing I can say is that it is infinitely better than the previous attempt at containers as a service called ACI or Azure Container Instances because that was embarrassingly bad. But this has a lot of potential.